Okay, let's take a look at homework one. First question. Set that contains nil elements. Well, that's called the empty set. So right inside here, we could just write empty. So, oops, sorry about that. Empty set like this. Also called the null set. And over here, we can use this symbol right here, which stands for the empty set or null set. You can also use a symbol like this. So there are a couple ways to do it. Either one of those is fine, or use those words. That's the word null. Okay. Let's see what we got over here. Now, if we go ahead and take a look at this next question, it says, express the set using the roster method. A roster method is a method where you list it out, and here this is called the set builder notation, where you have X and then a line. So X, such that X is a zodiac sign that begins with S. Well, there's two of them. There's Scorpio and Sagittarius. So right here, we're looking at this as being our answer. That's the only one of these that fits the question. Okay, let's take a look at one down here. Now let's express this set using the roster method. Something you need to know about this right here, this N right here, this capital N that we see right there, capital N is a set of natural numbers. Sorry, that looks like an F. It's a set of natural numbers. And that's you rule numbers. Getting used to this pen a little bit. Sorry about that. It's a bit weird. Okay, so what that means is you have a set start with the curly brackets like this, and it starts with 1, then 2, then 3, and then 4, and then comma, dot, 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 all the way off into infinity. So notice it starts with 1. And here it says between 4 and 10, but not including 4. So if we want to list this one in roster form, then what we'd have here is we'd have our curly brackets, kind of hard to make, starting with, well, the number 5, because 5 is bigger than 4, and we're not allowed to equal 4. Then we continue on, so we have what, 6, and here we go, 6, and then 7, and then 8, and then 9, and then we can actually use 10. So then we would close the set with the curly brackets like that. Sorry about that. So here we have a set of natural numbers over here defined. Fix that 4 a little bit out. It's even worse. Anyway, sorry about the messy numbers. We'll get that figured out here soon. So here's the answer to this one is 5, 6, 7, 8, 9, 10. And the reason that we're not using 4 is there's no equal sign here, but we are using 10 because there is an equal sign under there. Okay, let's see what we have here for the next question. It says, determine if the given set is the empty set. Well, here we have a set with something in it. What's inside it is 0. Now 0 is well, in numbers it's not worth anything, but it's actually a thing. So this is not the empty set. So the answer to this is no. No, there's actually an element inside there. See if I can finish my there. Okay. Moving on here, we have determine if this set is empty. So again, this is set builder notation. X such that, that's what that line means. X is a living Russian Tsar born before 1700. Well, I'm pretty sure there's not a living person born before 1700. So in this case, yes, the set of all of the living Russian czars that were born before 1700s would indeed be the empty set. So for this one, we can certainly say yes. Yes, it is. Yes. Okay. Okay, so let's go ahead and take a look now here at the next set of questions here and see what we got. We have determine whether the given statement is a true or false statement. Get this out of here. 32. Well, this symbol right here, the symbol underneath it here looks kind of like this. Kind of a rounded arrow looking thing. That means member of. That's defined to be a member of the set. Okay, now, so looking at this right here, is the number 32 in here? Well, notice this is going 15 and then 17 and then 19. And you've got 3 in a row, which kind of develops a pattern that they're going by odd numbers all the way to 33. And 32 is an, well, even number. So it would not be in here. So is this a true statement? Is 32 a member of this set? And this is going to be a false statement. Okay, I'll put false. We could just write, it'd be easier just to write a F in this case because this pen is giving me a hard time. Anyways, it's false. Determine whether this given statement is true or false. Not a member, sure. This goes from 1 to 7. 12 is, notice the line through it. So this is a true statement. And the reason it's true is because 12 is not a member of this set. Okay, we got one more. Here, x is a member of the natural numbers. That's 1, 2, 3, 4, 5, all the way to um, infinity. And x is even, means that both of these conditions have to be satisfied. 5 is definitely not an even number, so 5 is definitely not, and notice the line through it, a member of the set. So this is also true, so I'll just put a T there. Okay. All right, so we can take a look at this. The following sets are given here. 4, 5, 6, 7, 8, and 3, 4, 5, 6, 7. Are these sets equal? The answer to obviously this is no. So to be equal, they have to have the exact same elements in them, so no. However, just on a side note, they are equivalent because, look, they have the same number of objects in there. Notice they both have, what is that, 5 elements, 1, 2, 3, 4, 5 elements. So they are equivalent, but they are not equal. Now, coming down here with that information, let's look at these two sets here. Are the sets equal? Well, in this case, it's a little bit unnerving that they wrote it this way because you should never put an element more than once in there. So is 10 in here? 10's in here, yes. 12's in here, 12's in here, 14's in here, 14's in here, and 16's in there, 16. So the sets are both equal and equivalent, though this is not a good way to write the sets ever. You never want to have repeated elements in the set. So this is kind of a trick question, but the answer to this is both yes and yes, because here they do have the same number of elements, and they are exactly the same, even though this set is full of some repeats in here. So I would never do this to you on a test. So we can go ahead and just answer this one for the homework and say yes and yes. Okay, yes, and then yes for this one too. But it's not a very good defined problem. Okay, continuing with this work here. Are these sets equivalent and equal? Well, let's see what we do. We could write these out in roster form. This would be the set, and if I make curly brackets here, 10, 11, 12, but no 13 because I can't use it. So I have to go ahead and put the curly brackets there. And then that would be set A right there. This is set A. And then for set B, we have known 8, so it would be 9, 10, and 11. So just looking at these right here, they are certainly not equal, so no for the equal. But they are equivalent, yes, because they have the same number of elements in there. So yes for that one. Notice that they both have 3 elements. Okay, and remember they're n here, so that means that they're the natural numbers. Okay, so the difference between finite and infinite or infinite, is whether it goes on and on forever. Here we have a set of natural numbers, so we have the numbers counting from 1 and off to infinity. And we also have to be just bigger than or equal to 200. But notice that this continues on forever, right? Because this would start at 200, and then it would be 201. Sorry about the pen. Then 202, and then dot, 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 dot. Now remember, you always want to put curly brackets on a set like this. So this is definitely infinite right here. So there's your answer right there. Okay, so the symbol right here that looks kind of like a less than or equal to sign, but it's actually rounded, that means subset. A subset means it is going to be something that has the same members or fewer, but exactly the same members, or perhaps is actually equal. And in this case right here, notice that I have 1, 2, and then 3, 4, 5, and 6. So this set is 1, 2, 3, 4, 5, and 6. That's what the 3 dots represent. And this is 1, 2, and 3, which are 1, 2, and 3 are all elements here. So you could indeed, on this one right here, you could use the symbol that looked like this because basically it is a subset. That's what it means to be a subset. All the elements in here are in here. Notice that the 3 is implied by the 3 dots. Okay. Taking a look at these examples here. Even though there's fractions, they're just elements. 8 tenths is not in here. That's 10 eighths, and 15 over 14 is not the same as 14 over 15. So this is definitely not. So we're going to use a symbol that looks like the subset, but then we're going to put a line through it like that. So not. It's this symbol right there. I know I tried to make it over there. Here, let's make it here. We're going to do subset and then a line straight through it. Okay. Let's look at this one here. So this is the set where it's a natural number, and it's got to be between 3 and 7, not including 3 or not including 7. So that would be 4 and 5, and then, of course, 6. We can make that look more like a 4. There we go. And then, of course, the curly brackets here. That's what it looked like in roster form. Is that a subset of the empty set? The answer here is definitely neither. Okay. So there's just nothing about this as a subset of this. This empty set means a set that has what? Nothing in there. Not zero, but nothing. And therefore you can't have something with something be a subset of something without something. Okay, still working with this. Notice we have a subset of the empty set. Is that a member? Actually, that's not the subset sign. That's the member symbol. Remember this symbol right here looks kind of like that. Means member, member of. Okay, and this is definitely not a member of this set. Do you see it in there anywhere? So it's not a member of that set. It's not in there. This is not an element. Now, the funny thing about it, though, is it is a subset of this, but not a member. So here we go. This is definitely false. And it's all because of the definition of this. We do not see a subset, an empty set sign in here anywhere. So it is not. So this is a false statement. Down here, this is actually true because 1 and 8 and 8 and 1 are the exact same. Oh, wait, I see the line there. Never mind. This is false because this is a subset of that because of that line down there saying equals 1 and 8 is the same as 8 and 1. So this would be a subset, but they're saying it's not, so this is a false statement because the actual true statement would have this symbol right there. It is indeed a subset like that. Okay, for this next question, we want to calculate the number of subsets possible. So what we need to do is figure out how many elements are in here. So there's 1, 2, 3, 4 elements. So you see that? 1, 2, 3, 4. So to calculate the number of subsets for the set, you do 2, it's always 2, raised to whatever this number here, in this case 4. Okay, and of course that's equal to 2 times 2 times 2 times 2, which is 16. Okay, now to be a proper subset here, that means that we take out the one where they're equal. So of all the 16 subsets we could make of this without the one equal, so the answer to the number of subsets is 16. Then all we have to do for the proper ones, for this one right here, well, this is equal to the number of proper ones, number of regular ones minus 1. So that would be equal to 15. All you do is subtract 1 from this. So we can do the same here. We just need to know the number of items in here. Notice that we're not equal to 9 and not equal to 13. So that would actually be in a set form 10. Sorry about that. There we go. That's a 10. That doesn't look like a 10. There we go. 10, 11, and 12. That's it. Because we have, here's a curly bracket, because these are not included because there's no equal sign there. So there's actually 3 elements. So we would do 2 to the third, which is then going to be 8. So that's the answer to the number of subsets. And then the proper subsets, you just take 8 and subtract 1 to get 7. Okay. All right, you should be able to get most of the problems now from section homework 1